Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about the flame detectors that I described in the past videos are connected to programmers that can range from a simple flame failure alarm to a complete startup and shutdown programming of the installation, including pre-purge phases, which is to clean combustion chamber completely before each ignition, pilot and main flame supervision, post-purge, interlock switches for atomizing vapor pressure failures, control air pressure, power supply, low leveling boiler, exhaust fan forced air, etc. The detector programmer system must be able to detect the flame in the shortest possible time. As an example, let us point out that in thermal flame detectors, the response time is of the order of 1 to 3 minutes. In a gas burner with a power of 600,000 kilocalories per hour with an approximate consumption of 60 square meters per hour of natural gas, and in the event of a flame failure, the thermal detector will need 1 minute to cut off the fuel flow. And during this time, 1 square meter of gas and 10 times more air would have entered the combustion chamber, totaling 11 square meters of potential explosive mixture. On the other hand, an electronic system would have acted in a time of approximately 1 second, the volume released being only 0.2 square meters. The system should also have a self-test of its components at each startup. We might think that many explosions can occur in an installation, but this is not the case, since for an explosion to occur, synchronized failures must appear. That is, component failure and flame or ignition failure must occur within the same cycle. The possibility of this happening is remote. However, as the number of operating cycles decreases, the possibility of double failure increases, since the time between the running responses and therefore between the component verifications is longer, which is what happens in navigation or in industries that only stop limited times a year. Under these conditions, total protection is achieved with periodic self-test of its components while the boiler is running. If a flame failure simulation occurs, the self-test device will prevent the burner from starting, or if a periodic self-test is available, it will stop it while it's running. Periodic self-testing while riding is accomplished with an ultraviolet detector fitted with an oscillating diaphragm that fires 50 to 90 times per minute, in accordance with the pulses emitted by a relay in the controller. Thus, the flame is no longer seen by the detector, and the pulse relay ensures the self-test of the circuit once per second. Any defect in the electronic components of the detector and the programmer leads to a safety stop in about 4 seconds. The microprocessor controllers provide a continuous logical check of the entire circuit, the detection and solution of faults, the optimization of pre-purge and post-purge periods with consequent fuel savings, and the automatic startup and shutdown sequence of the installation. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I will upload videos every Wednesday in Spanish and every Friday in English. Adios! We are the champions.